Can I have a motion to approve the agenda?
Make the motion to approve.
All in favor? I don't know, if Mr. Bonfils is he on?
He is on. Mr. Bonfils?
Yeah, yes, please.
Okay, let's get into the first action item. Approval of a study task order, wastewater collection system master plan.
Good morning. Good morning. I'm Darren Geldert. I manage our planning team here, and with me is Andrew Beatty, who's our manager of planning initiatives. And we're really excited to be here today to ask approval related to our wastewater collection system master plan. And this is specifically one piece of that, the model development. We will be back probably in the spring or late winter with the full collection system master plan scope. So we'll talk a bit about that today and then get into really what this scope is, which is the model development. So when you step back and look at the whole master planning process, there's a whole bunch of pieces that go into it, and it all builds toward eventually some improvements. And we're actually getting underway with flow monitoring as we speak. It's something we do all the time, but this is going to be more intense so we can then make sure we know what's happening in our sewer system. This scope is related to the model development and the calibration of that model so that we can both tie our actual flows that come from all our houses and residences, businesses, but also include the influence of rainfall and I&I, rainflow and infiltration. We will also then tie in a development of future flows by looking at our projections for residential, commercial growth and data center growth. That is actually also underway, and we're developing some projections that will feed into a water master plan, a reclaim master plan, and this wastewater collection system master plan. And actually all of our divisions will be able to use that data. Then eventually we'll come back, and this is what the next scope will really be, to tie that all together, to do the analysis, to look at our existing system, and eventually come up with some improvements. So as we walk through the process, we'll actually have a whole bunch of different outcomes as we go through it. So some of the first outcomes will be related to flow projections. Then this is really going to work more on the model development to expand that model. With those tools, then we'll be able to look more at our capacity in our system, make sure that we are projecting for the right level of service that we want, address any deficiencies, and then develop a capital improvement program, a series of system improvements that would be timed or triggered based on development. And that would include pump station improvements, perhaps new pump stations, piping improvements, and so on. This will give us a roadmap into the future. So we're always planning, and we've always been doing this, and we've been doing a lot of area facility plans recently, like related to the JLMA and other areas. So why are we doing this master plan? Well, the master plan can really help us answer some of the big picture questions that we have. Because our system is extended and it's all interconnected, what happens upstream impacts what happens downstream, and it's very dynamic with the influence of rainfall and other demands. So this will allow us to really look at those big questions and get a good baseline. We've done this before back in 2016, but a lot has changed since then. And so we really need to update this as a comprehensive system and tie all those different little pieces that we've done together. So with these tools that we'll develop, we'll be able to do better analysis, make better decisions, and hopefully then also improve the communication of those decisions to everyone through some different tools that we'll work with. So why the master plan now, you might say? Well, it's because a lot has changed. And we've been working on these changes, but this kind of will help us tie it all together. And that includes our service area expansion, the new policy area classifications tied to the general plan. Obviously, data center growth is impacting things, and those are really actually tricky planning for because we don't know how much water they're going to use. Some are very heavy water users, some are not. And then we also had a lot of in-house data tools that we've built or that we've deployed, including AMI, which is advanced metering infrastructure. We now have meters that we can look up at every location, hourly data. We have new analysis and visualization tools with Power BI. Our asset management team has done a ton of work looking at our system, and we're going to help bring that all together. But kind of the first part of that, one of the real keys to that will be this development of the model. And Andrew's going to talk a bit more about that.
Okay, thank you, Darren. Darren did a great sort of overview of the bigger picture, but diving into this specific scope of work and the task order that we're looking to secure approval for today, I've broken it down into the 5 main components for this work. First of all, we'll be gathering and reviewing our existing data. This will include our existing hydraulic model, our GIS data, SCADA data, as-built, as needed. We've budgeted for some limited field work, and we know there are still some older areas in the older parts of our system where we may have questions about the GIS data, and just making sure pipes are connected the way they're supposed to be and such. But that's just limited and will be used as needed. The bulk of the work is really in the model expansion and then the data evaluation and the inflow and infiltration analysis. The model expansion I'll touch on a little bit more on the next slide, but it's primarily to get all of our pipes and all of our manholes, all of our pump stations, all of that built and included into our hydraulic model. For the data evaluation and inflow and infiltration analysis, this is related to the flow monitoring that we've begun, and really this portion will be disaggregating that data, trying to establish what our base flow is, what our groundwater infiltration is, the impact of rainfall on our system, and we will use that data to then calibrate the model. So this is a very important step because we want the model to accurately reflect the response of the system.
What kind of accuracy do you get at any one point? In other words, how accurate is the model?
It's a great question. I guess the last time we did this, we had developed just a very skeletonized model. So we'd focused on modeling the larger pipes of our system. And so I think with what we're going to do is move to an all pipes model. I think this will better reflect and provide more accurate results, but I don't know, I can't say, but the calibration, we will document the results of the calibration to show what that accuracy is.
I was just curious.
I have a couple of questions.
Yeah.
One is related to the urban planning areas.
Yes.
We don't have urban planning area data of existing urban developed land.
Correct.
In our network. And the 2 major cases are Bravana, where you got the horse pen on outfall, and then you've got Moorfield.
Yes.
One I'm familiar with, one I'm intimately familiar. And both of them lack mixed use flow data. I mean, how are we anticipating developing that data if we don't have any in the county?
It's a great question. I think we'll probably look to our peers as well to see if we can gather any insights from what they're seeing. It is still a challenge because we don't know exactly what development will be approved there. I mean, the Ravana development, they've got quite a wide range of projected flows, and it'll all depend on market conditions ultimately on what will be built. But we will be conservative in our planning and then sort of adjust from there as the development progresses. But it's a challenge.
Yeah, it is a challenge.
It's an unknown.
As a friend of mine used to say, there's a lot of stuff planned for those 2. And all that stuff has got to go somewhere. And all that stuff is going to need downstream capital improvements just to handle the flows, whichever way they come.
Yeah. Yeah, and it's the advantage For us, I'll move on. The last component of the scope of work is just developing a tech memo to document all of the work that has been done, summarize all of that, and then note the sort of future steps that would be needed or recommendations, which could be more flow monitoring, for example. So this slide really demonstrates the extent of what the improvements to the model that we're looking to do. As I mentioned, back in 2016, we had a very skeletonized model. We'd modeled about 200 miles of pipe, 11 of our major pump stations, and our single siphon structure at the time. And the reason for that was that this was our first time developing the hydraulic model. We didn't want to bite off more than we could chew. We wanted to see what this could do for us. And since then, to bringing us forward to today, we want to model all of our pipes. So that's approximately 1,100 miles of pipe now. We have 26 pump stations, 2 siphon structures, and we're a lot more confident in our GIS data. And this model will give us more flexibility to analyze new development as it comes online. One of the other challenges that we foresee coming is redevelopment as well, where we may see data centers being proposed in areas in the very upper reaches of our sewer system that may or may not be able to sufficiently handle their flow. So this new model will allow us to model that and see what the impacts downstream will be. So that'll be one of the major benefits to this model. In terms of schedule, this is just one piece that fits into the larger master planning program. As Darren mentioned, we've already started some of the projections work and the flow monitoring work, and this is really the model development component of this. We're expecting this work to take about nine months, and some of that timeline is just due to waiting for the flow monitoring work to be completed in order for the model to be calibrated. And then from that, we'll also be bringing forward the full master planning, the sort of remainder of the scope in either a single task order or multiple task orders, depending on how it makes sense for that to be broken up. But ultimately, we would like to get this work completed in sort of the middle of 2026 or the fall of 2026 to allow us to use it. But we'll be able to use what gets developed, the tools we develop throughout the course of this and as they get finalized. The budget for this task order is shown here. Again, I'll note just that the majority of the work is in the model expansion and then the data analysis from the flow metering. So we are looking for approximately $141,900 for this task order. And then this is just our CIP project snapshot for your reference. And this is the last slide before the motion. So happy to answer any other questions you may have.
Just curious, you mentioned the skeletonized view that was done previously. What was the cost associated with implementing that, putting that into effect? Do you have any idea of what that may
That
have
was
been?
back in 2016. The entire master plan was
That was about $400.
$400,000
$400,000 approximately back then. So that would have been a component of that.
So this is significantly less, but it sounds, is it due to like lessons learned or in terms of the initial?
Well, this is just this task order is really on just the model, not
Oh,
the
okay,
entire
right.
master plan. That cost was for
Okay.
more of the entire program.
It was just get an idea of reference for what was done before versus what's being proposed right now. That's what we're trying to get.
I think last time we tied it all together, so the model development was brought up with the whole master planning scope. So it was one big piece. This time we decided to break it out. Hopefully we can develop an even better scope by getting a little bit more work kind of in the bank first. So then when we come back with the scope, it'll be a a little better focused.
Okay.
But- So it's a little tricky to compare.
Is there any type of cost benefit analysis that's being performed to understand, the benefit? I know some of it may be indirect, but just trying to understand, is there a cost benefit analysis done in a situation like this?
To do the planning work, I'd say no, not necessarily, not really. But I think as we look at all the alternatives that get developed out of this, we've traditionally seen a great benefit in that and being able to use these tools and do the desktop analysis before we go into a full design or oversize something or undersize something that gets out in the field.
Yeah,
So
the model will allow us to do better scenario planning.
I think this is fascinating. I mean, the whole model calibration aspect of, I mean, a lot, as you stated, a lot has changed between 2016 and today. I would think all Wiley and Wilson flow numbers that we all used for a long time will have changed. And assumptions that we made for office space flow generation and for maybe not so much residential, but mixed use data centers. There's just a whole host of different industries and different use habits that we've developed around the spaces that we work in. That I think it's worthwhile. The calibration part is the one thing that really excites me because it's really going to give us real view. I think there's still a sense of the unknown when it comes to urban planning areas, just because they are not very discrete. They're all jumbled and mixed, and in trying to identify where from a mixed use building the flow is coming from is it's kind of a little sorcery, not engineering.
And I wanted to add, I think, to the earlier question about that very part of this. I had the benefit of a briefing recently on some of the parallel work that the planning department's doing with our flow projections overall and the way in which we're able to dig in and slice and dice that information and develop tools that are flexible. I know Power BI was mentioned, and just kudos to the team because that, in combination with this way in which we're looking at it with this next go round of the plan, is going to lend us a lot of flexibility to continue to take in information on the fly as we learn more from these new areas. So I'm excited for that.
So with that, I'll offer
is there another question?
I just have another, this is a little bit broader. I'm just curious, we're talking about Power BI, it's a data visualization tool. I was just curious, within Loud and Water, is there any thought or leveraging some of the AI tools or leveraging an AI tool in terms of analysis, that being thrown on the board or could be considered right now?
I think it's definitely considered.
Okay.
I don't think at this point we really have a great use case for that.
Okay.
I know that at the wastewater plant, they have been doing some, I don't know if it's AI or machine learning, to help look at predicting how they dose some of their chemicals, because there are so many variables involved in that process over there. And I think we're continuing to look at those, options. There are a lot of software vendors out there selling or trying to sell us tools that will help us with the analysis or make better decisions. It's difficult to tell how well they'd work for us sometimes. So
Until a use case.
yeah, we're keeping our eyes open, but
Yeah, for that perfect use case, it would make sense. Understand?
Yeah,
do you want
I
to?
just wanted to add on that, another use case that has been done in other places is predicting the effects of wet weather. And that AI model is built based off of this. So we need this model first, and then you run a whole bunch of scenarios from that, and the AI learns how our system responds to wet weather. So it's another, potential use case, but you need these foundational models to run those scenarios. So this is, kind of step one into getting to this.
So this will be additional data point for a downstream use case potentially.
Yeah.
Okay, thank you.
Just in general, I just say that the accuracy or working with trying to calibrate it, it's really tricky on the sewer side. Because we have, yes, those base flows, which are based on the development that's there. But then we also have the influence of rainfall, and as our system ages, will we get more leakiness into the pipes? Perhaps, but we may also get more conservation from the users and trying to balance those and see how the system reacts. And as we do rehab, it continually changes the system. So it's fun.
Are there any other questions?
Questions?
I'll make the motion. I move the recommendation to the board to award a task order for the wastewater collection system master plan model development to Carollo Engineers for an estimated cost of $141,900 with an approximate 5% contingency to be controlled by the general manager for a total authorized budget of $149,000. Additional costs will require board approval, and I'd like to put this on the consent agenda. Can we, all those in favor?
Oh, second.
Second.
Oh, second.
Yeah.
All those in favor?
Aye.
Aye. Thank you very
Aye.
much. This is fascinating.
Thank you.
Okay, the next item, award of contract for the pre-procurement of the Phase 3 project thermal dryer and special engineering services.
All right, good morning. I'm Rick Zafel, and I'll be requesting this authorization to award the contract this morning here. So my agenda for this morning here, so we're going to talk a little bit about the broad run process overview and the benefits of a thermal dryer system. Then we'll go over justification for using the pre-negotiation and a sole source as well in this procurement effort. We'll talk about the Andritz dryer system pre-negotiation process. Andritz, by the way, is the company whose product we are selecting here. And then we'll go through the package 2 procurement schedule. We'll also talk about the cost components relative to the CIP, and then get to our recommended motion. Okay, so for the broad run process overview, generally, the light colored processes are existing processes at broad run, and then the dark colored processes are new processes that will be expanded or added as part of the Phase 3 expansion. And today our focus will be on thermal drying here. So thermal drying will be new to the broad run facility as part of Phase 3, and it will be included in the dewatering process and solid storage. There'll be a building that houses all 3 of those as part of the Phase 3 expansion. And so some of the benefits of thermal drying are, number one, it will expand the biosolids treatment capacity beyond what we currently have at broad run. Number two, it will reduce the biosolids hauling costs. So right now we produce a Class B biosolid, which is still has about 75 or 80% water in it. And we'll go to a Class A biosolid with the thermal drying process, and that has 10% or less water in it. So a big reduction in water and the associated hauling. And then a Class A biosolid has more beneficial use options as well. There are more end use possibilities for it. And then last, another benefit of thermal drying system is enhanced biogas utilization. So just a real quick detail on that. So our anaerobic digesters produce biogas, and the plan is to use the anaerobic digester biogas as the primary fuel source for the furnace in the thermal drying system. Okay. All right, so the justification for pre-negotiation. So we've got our 2 parts here, and part 1 is the special engineering services. And so this dryer system, it's a specialized equipment package. And what we'll do is we'll get early shop drawings from the vendor, and it'll result in a consistent and complete vendor design And the idea is that that vendor design will fold into the larger package 3 design, and it'll connect, all the connections and interconnections will be sorted out and complete and well developed. And once that happens, we'll take the completed design and we'll go to part 2. And with the clearly established lines of responsibility between the vendor and the contractor, again, the vendor's providing their smaller design, which folds into the larger project design. We will assign part 2 to the general contractor who's going to build the project. And the contractor will handle all the equipment and they will manage the vendor performance. So they'll be responsible for seeing to it that the equipment is brought to the site, installed, commissioned, and operational before Loudon Water takes ownership at the very end after substantial completion. So the beauty of this process is that Loudon Water is not responsible for taking ownership like in a pre-purchase arrangement or something like that. We don't take it until the end. Okay. Any questions so far? Okay. So our justification for sole source. So we've selected the Andritz rotary drum drying system, and earlier in the design of the Package 2 project, we looked at different drying systems, and we determined that this drying system was the best for Loudon Water. A couple reasons. One is that it accomplishes the most drying in the smallest footprint, so you don't need as big of a building. And a second reason is that the product from this drying system is a pellet. It produces pellets that are about 0.5 millimeter to 4 millimeters in diameter. And these pellets are very easy to transport. They're self-consolidating, so they're very versatile in the sense of handling and also end use as well. And so that,
Question.
yes, sir.
With the Class A biosolids, what are you doing with it? Is it going for fertilization?
For land for
For
land
land app.
application. Mhm. Okay, so on our graphic here on the right, so we'll go around and, as far as the Android system, a couple other justifications for the sole source here. So it's a very complex and proprietary technology as well, and it also fits into kind of a niche market. There's not a lot of players in this market. Andritz is a proven manufacturer of sludge drying systems. They've been in the business for 50 years or so, providing these drying systems. And then also they have several successful local, national, and even international installations for the good track record of the company and of their rotary drying system. And the graphic here on the left is just a schematic of the main process train for the dryer system. It doesn't include necessarily everything, but sort of the core of the drying process is represented by this. I'd be glad to walk through it, or we can just move on. Would it be helpful to just take a minute or two and walk through that?
Yeah,
Okay. All right. So we'll start at the cake bin. So our Class B sludge cake is collected at the cake bin, and that Class B sludge is mixed with recycled pellets right here. And the two of those together are mixed in a plowshare or paddle mixer, and then they're introduced together to the dryer right at the head of the drum. And so we have the furnace providing the heat into the drum. It's a triple pass drum. And so inside the drum is rotating, okay? And inside the drum, the recycled pellets act as the core or the nuclei for the forming pellets. And there's a process of lifting and moving as the drum rotates. The pellets make their passes through the drum and form. And so basically that cake sludge, it forms in layers on those nuclei, or the word is accretion. It kind of accretes to those nuclei. And then the combination of the gas stream and the pellets come out. They go to these separation structures here. There's a pre-separator, a plate separator, and then also a sort of polishing separator, the polycyclone. And the pellets are collected or separated out in these two. And then there's a shaker deck or a screener that classifies the pellets. And so optimal size pellets go to a pellet cooler and then go to a pneumatic transporter that conveys the pellets to a storage silos. The undersized pellets are returned to the recycle bin. Those are the nuclei or the core that form the new pellets. And then also the oversized pellets go to right here. There's a crusher that crushes the oversized pellets, make those into smaller components as well that also go to the recycle bin and serve as, again, the nuclei or the core of the forming pellets. And then, oh, go ahead.
You mentioned that there are other manufacturers who do this. Is the process exactly the same, or it's
There's not, in the US, really Andritz is,
that's the only?
yeah. Okay, real quick on the gas stream. So when you inject the heat into the dryer, you get very humid air. You separate out the pellets here. That humid air is moved along by this large fan. And what we do is we take the air through a condenser. So all that humidity is pulled out of the airstream. The airstream returns back to the head of the drum and is recirculated through. And then, so it's about 90% recycle or closed loop. The 10%, you have a small portion of air that is pulled off. It runs through a scrubber to get the rest of the particulates out. And then it goes down to a regenerative thermal oxidizer, which basically just oxidizes out VOCs and odorous compounds. And then the 10% that you take out is replaced by the combustion air that's added to the furnace to support the flame. So you have kind of a balance there with what's taken out and what's added in. And that's, in a nutshell, that's generally what's happening in the dryer system. Again, there are many more complex, supporting systems and such that aren't really shown here. Any questions? Okay. All right. So our pre-negotiation process. So it began with an RFP. So that was developed last year. It was issued this year, and we received a proposal in June. And so we've been negotiating with Andritz, with the selected vendor here, for several months now. And we have conducted, upwards of 10 meetings with them. We've negotiated over 200 comments, and we've really worked with Andritz. Our negotiating team had experienced personnel that are familiar with the Andritz system, both from Hazen and Loudon Water. We've also benefited from some lessons learned on past projects as well from Andritz and Hazen as the design engineer for the Package 2 project. And so those things have worked to help achieve the best value through these collaborative negotiations. And another thing too is in the negotiations, we've also been able to advocate for preferences and needs for Loudon Water. I'll just give an example of that is longevity. We're seeking to get components and systems that will give us the greatest longevity so that we have the most time to really get acclimated and comfortable with this dryer system before we have to do any major maintenance or anything like that. So all those things have gone into the negotiations to really achieve what we believe is the best value for a rotary dryer system at Loudon Water. And then, of course, the next step or the last step here would be to award the contract to the pre-selected vendor. We hope to do that later this year or next year, early next year.
In the future, when you have to get parts to replace, do you have to go back to Andritz for the parts?
Typically, yes.
And how do you determine the cost of those pieces that you might need?
Well, one thing before that, we're going to get a healthy amount of spare parts with this. And so those will be the key spare parts that would typically be wear items or replacement items. So, that would cover us near term, but I think maybe in the long term, we would probably have to go back to Andritz for major items, but that's years out.
What is the life cycle?
20 plus years is what we're buying with this system.
You mentioned Andritz is really the only player in this space.
That's
in the
correct.
US.
That's correct.
So did no other vendors where you can get to?
There's no,
Well,
yeah.
I just want to clarify that a little
Okay.
bit. There are other dryer manufacturers, right?
Yes.
Just, they all make a unique system. And we did, in the planning stage of this, evaluate all the dryer manufacturers that were available and went through an early selection to say, yes, Andritz makes the best cost value benefit for us. But there are other manufacturers. They don't produce at this scale. They produce very small units. So we would have to have an army of them.
Okay.
And they also have maybe 1 or 2 installations here in the US. So you run into situations like talking about spare parts. When we're all using Andritz, Andritz has huge warehouse of spare parts for us. When it's 1 installation in the US and they're in Europe, you wait for your spare parts to come on a boat, right?
Okay.
When you need them. So that evaluation was done early. So there's no direct competitor, but we did look at all dryer options to make this
So
selection.
there was that down select process to get to.
Mhm.
I understand. Okay, thank you.
Okay. So this is the schedule for the larger package 2 project here with design already underway. And so the part 1 special engineering services, or the Andritz design, the idea is that would run concurrent with the package 2 design. And again, it would fit into that package 2 design. And then once we fast forward to construction, the idea is that the part 2 goods and services would be provided during heavy construction, received, installed by the contractor during the construction. And we anticipate that to be sometime after 2027. Okay. Okay. Now for the cost here. So we've got our part 1 and our part 2 costs. And again, the part 1 is the design. It's an Andritz design, and it represents numerous submittals, drawings, coordination meetings, vendor coordination with Andritz's subs and suppliers, and as well as with Hazen and Loudon Water. And it's also comparable to recent projects as well that Andritz has done in the US. And so the 1.4 million, it is buying that cohesive design, or that well-developed design that would again fit into the larger design. And if you didn't do the design now during the larger project design, it would have to be done during construction. Okay, so it's better to do it now when you have the time, rather than during construction when time is of the essence and things are moving faster. And it could cause a delay. Could. So it's better to be upfront with this vendor design, and then moving on to part 2. So the 26.7 million represents yes.
So when they're doing the special design, and I guess it's the vendor doing the design.
The vendor's doing.
Are they the engineer of record then, or?
No, Hazen is the engineer of record for the project. Andritz is just the design vendor, or the specialty design vendor. But a lot of, coordination between the two. Yes.
The other thing is so until they get through the special engineering services, that the cost associated with the actual dryer system could change. Is that correct or not?
It could change, and there are provisions to deal with escalation.
Okay.
So the second part here, the 26.7 million. So what that buys is the complete dryer system. So it's about 30 to 40 major components or subsystems. Okay, and just to give you a kind of a picture of the size, it represents over 30, full-size tandem truckloads of materials. So it's quite a bit of materials. And it also includes all systems. So it includes all the electrical gear, like the motor control center, switch gear, variable frequency drives. It includes the entire control system as well, all the SCADA screens, the processors, the control panels, the operator interface terminals. all of that is included as well in the system, including all of the mechanical components. And I haven't said it yet, but what we would be buying there for part two, for these dryers, they're measured in terms of water evaporated. And so we'd be buying the DDS 60 system by Andritz. And so what that represents is that it can evaporate 6,000 kilograms of water per hour. And that equates to 13,200 pounds per hour. So that's the capacity or the rating of this system. Okay.
If this is a standard, standard system, is there that big an effort on shop drawings? Aren't a lot of these parts standard?
It's
still
standard
need to
parts,
shop
but it's a
them.
custom design because it's totally unique to our needs. And it's kind of a client specified custom design that they're doing. They are familiar parts. I mean, that certainly there are parts that carry over to the different models that Andritz makes, but it's a custom design. Okay, and just again to add, we have put a lot of time into the review and negotiation of the Andritz proposal. Again, we've been spending the last 4 months or so working with Andritz to come to agreement and get the best value. Yes, sir.
When you're referring to thoroughly reviewed and negotiated on
Mhm.
part one, where did we start to work our way down? I'm assuming we worked our way down and up to 1.391 and on the 27 million, where did we start and what did we negotiate down?
So we had to work our way up on the design because the design is so extensive. And it's so detailed. And I think that price is very comparable to an installation that Andritz did in Clarksville, Tennessee, very recently, slightly smaller size dryer, but comparable. And that's how we arrived at the 1.3. They were in that ballpark with that Clarksville project. And so, all of the effort and collaboration that Andritz had to do with that particular end user went into determining that cost.
And on the part two,
On the part two, it was very comparable to the original proposed amount. Again, I mentioned that there were some things that we added to promote longevity. I'll give you a quick example, bearing life. Andritz offered 50,000 hour bearing life. We said we need 100,000 hour bearing life to give us that longevity, to make sure that we have that time under our belt before we're doing major rebuilds, because this is it's a new system to Loudon Water, and so we want to be able to get acclimated to it before that kind of maintenance. Okay, so my last slide before the motion here is just the CIP snapshot, and it shows that we have allocated in the 10-year CIP 391 million for design and construction efforts related to the Broad Run Phase 3 work. And so this, of course, would fit into that as a subset. Any further questions before I go to the motion?
No,
no, thank you.
Okay.
Before I read the motion, I'm assuming we go for consent. I don't see any reason to go for action.
Yep.
Unless you guys think so.
No,
I think so.
if it falls within the CIP estimated.
All right. I'll read the recommended motion. I move the recommendation to the board to approve award of a contract for design of the Broad Run Phase 3 package to rotary drum dryer system to Andritz for $1,391,346. In addition, I move the recommendation to the board to approve award of a contract for the Broad Run Phase 3 package to rotary drum dryer systems goods and special services to Andritz for $26,728,860, which will be assigned to a general contractor, and move this to the board consent agenda. All in favor? Oh, second.
I'll second.
All in favor? Aye.
Aye.
Thank you. Very good presentation.
Thank
Very,
you.
very good. I actually understand what you said.
And what was the timing on this as well? What was, from the master plan, what was the timing for this?
So,
Go back a couple of slides.
Yeah,
Yeah,
I couldn't remember what.
Because I forgot to.
Yeah.
was it
Okay.
this one that kind of showed how it all
Yeah.
fits into the package 2 project?
Yeah.
Yeah. So, yeah, we'd like to get started, next year on the part 1 of special engineering services, or as soon as we possibly can. And then the part 2 would be a piece of the larger construction there for the package 2 project. And that's 2027 and thereafter on the package 2 project.
So you were saying with part 2, where they're actually, doing the implementation of this, it's been spec'd out.
Mhm.
There's not likely to be any additional cost because it sounds like the components are our standard components, but they're fashioning them in a different way for Loudon Water.
Right.
So,
And when you get to part 2, the Andritz design is done.
Mhm.
It's complete. It's connected to the larger project.
okay,
And so we don't anticipate any more design effort needed
Okay.
once you get to that part 2 stage. It's really just bringing the equipment out and installing it and then commissioning it.
thank you.
Does Blue Plains have a system like this?
No, the closest ones are the town of Leesburg has one and Uosa to the south has one. Yes.
Are they, is Yosa's comparable size?
Uosa's is a DDS 40, so it's like 2/3 the size of this one. That was installed from 2012 to 14. I worked on that project, so I'm pretty familiar with it. And it's served them very well for 10 plus years.
Thank you.
Okay, thank you. Next item is information item, capital construction quarterly report.
All right, good morning, everyone. Rick and I will present our third quarter of 2024 capital construction report this morning. As we typically do for these, we will highlight 2 of the capital programs, projects that are underway and follow it up with our deeper dives into larger projects, in this case, Milestone and Route Run Expansion Phase 2, and then get into the overall statistics in a report for the third quarter towards the end of the presentation. The first project to highlight here is the Goose Creek Industrial Park Pump Station and Force Main Project. We've highlighted this one before, bringing it forward as it approaches the end of the physical construction stage. Prior to installation of equipment and startup and commissioning of the equipment, things are proceeding nicely right now. Value through the third quarter, roughly about 3/4 of the overall contract value. Control building is in place. All the subsurface structures are in place and waterproofed, and the electrical equipment, thankfully, which is, typically what we see delays on these days, has been installed. There's still a little bit of ongoing work on the force main, but not too much, about 500 linear feet left before we wrap it up. Should be done by the end of the fourth quarter. There's a little bit of yard piping, mechanical and gravity sewer improvements on the existing sewer lines that run out to Cochran Mill and beyond. As I mentioned earlier, startup and commissioning, and then one important component of this, towards the end of the project, we will decommission the original water treatment plant, wastewater treatment plant rather, that was on the site upon which this project is being built and currently still in operation. So that's a lagoon system that we will drain, restore, backfill, and have in place, perhaps in the interim, to support milestone efforts, which are pretty much adjacent to this property. On the Lansdowne SPS reliability upgrades, this is part of our efforts to bring relatively older pump station back into DEQ and Loudon water reliability and redundancy standards. So needed a little bit of work to replace some electrical equipment, some controls equipment, some exterior improvements as well on this project. That picture shows the existing generator coming out of the facility there. This one had a pretty lengthy procurement period before work could get started in full. Preceding the start of the work, we also have a bypass of the obviously of the flows to the pump station so that we could undertake all these improvements. That's all underway now and proceeding nicely. No major issues to report at this time. Under construction, we've completed the bypass. We've completed the extraction of the existing generator, decommissioning of the existing equipment, and are starting to work on its replacement. Obviously, with these types of projects, we have the bypass on a very well prescribed constraint. What do you call it? Constraint on performance. That's prescribed in the contract to sort of incentivize the contractor to, get going. Time is of the essence. Get it all done. So our exposure and risk is controlled. So far, they are on schedule. Installation of the new equipment is ongoing. Exterior improvements are underway. It's looking good. ACE is the contractor on this project. And with that, we'll get into a little deeper dive in Milestone. I think probably don't need to revisit the drivers for this one. Completed work. We've actually made really good progress on the excavation of the tunnel A to the quarry. Again, from our 35-foot, 270-foot deep shaft. We've started excavation of tunnel A towards the quarry. The original schedule showed that daylighting at the quarry around the end of the year. The current projection is that we will see daylight next week. So pretty well ahead of schedule there. The quarry has been partially dewatered down to the point where we can pretty much perform all of our work related to tunnel mining and improvements at the quarry, and completed, I guess, at the end of Q3, right? Quarry safety scaling around the exterior wall of the quarry to ensure that when we do daylight and construct other features of the workers are safe. So that's pretty well completed at this time. In terms of ongoing work, we do have our permanent bridge under construction. If you were to visit the site today, you'd see our temporary crossing across the creek and the construction of the permanent bridge pretty much proceeding adjacent to it. So far going well. Tunnel A excavation, like I said, 70% complete at the end of Q3, but since we are a little bit deeper into the month of October, we are pretty much seeing close to 100% completion on the initial excavation. The WNOD trail is set to be rerouted in a small section that we need in order to open cut the existing trail and install our 42-inch transmission mains. So that work is also constrained. It's set to happen between the months of November and April so that the public exposure factor is limited while we open cut and detour the trail. The detour is now approaching its completion. And so we'll just we'll hit our marks and hit the ground running at the beginning of November. And once the pipe is arrived and we have to open cut, it'll be ready for service there.
Is that a paved detour? Or
It is.
gravel?
It's a paved detour roughly along the abutment to the pump station site. And then it meets the trail at a reinforced concrete pad that we are currently using in case of any crossings along the trail. We want to mitigate the impact to the existing trail and the detour so that, we're not leaving ruts with heavy equipment that could then cause issues for bikers or trail users, things like that. We have been working in close coordination with Nova Parks on this, and so far, knock on wood, no public complaints, which is a pretty, I think, a feat I'm pretty proud of, given that we have not just this project, but GCIP, the prior project that we presented here, has a component of a force main line crossing along that trail as well, which sees heavy activity. And so I won't lie, I was a little bit apprehensive coming into this in terms of public impact. So
Then be careful. It's like that when the TV announcer says this guy hasn't missed a field goal in 55 tries.
I'm aware, but once I get going, I can't stop. Pre-excavation of the 42-inch raw water pipeline, that's also intended to support efficient installation, right? We don't want to get to the trail and then find that we have a bunch of rock to deal with. So we've done a lot of pre-hammering to make sure it's pretty well broken up. So when we have to go in, constrained by that restriction, we can just get the pipe installed and get going. Here's some of the stats on the project. Just roughly based on percent spent and time elapsed, you'll see that we are proceeding actually well ahead of schedule, probably about a month by my estimation. Substantial completion due date remains April of 2028. And we've had one change order so far through the end of the third quarter for 2024 to address some subsurface conditions that we found during that excavation period. And it was about $120,000 there. So picture shows sort of a typical blasting preparation phase sort of scenario. Get a little bit into more of the tunneling in a second after this slide. So just in general, communication between the parties gone well, coordination with the facilities that this new reservoir connects to, right? Trap Rock and the Potomac Raw Water Pump Station. We'll see more impacts and more coordination when we start commissioning in the third quarter of 27. Right now, proceeding ahead of schedule, like I said, working well through open claims, no delays claimed or reported. And actually, I think this second change order was executed after the third quarter, and I think I got ahead of myself and introduced it here as the, but we'll present more on that when we present the fourth quarter report. So here, when I last presented a highlight on this project to the committee, I showed a little model of where we were at with our shaft excavation, and I promised that we'd do a little bit more to show progress as we went. This represents those efforts. This is data collected by Schnabel, our inspections service provider in charge of all geotech inspections associated with the project under our RE contract. And it basically consists of, I guess it's safe to say, millions of points gathered in space using LiDAR. As we excavate the tunnel, we collect this data to retain good information on the quality of the rock, the alignment, subsurface conditions, any faults that we encounter. And as we go, we can use that data that the inspectors sort of collect routinely anyway to produce this model and get a really good picture of where we're at and what's going on. So this roughly reflects end of third quarter progress. And hopefully the next time we present this on the fourth quarter report, we will show that first tunnel A daylighting out into the quarry and, have a good journey to take you guys on as we keep making progress there. And I think that's the end of my report, unless we hear any questions.
Thank you. Thank you.
All right, switching over to the Broad Run Phase 2 expansion here. So we are getting close to substantial completion with this project, but we're not quite there yet. Our change order total stayed the same through the end of the third quarter. You can see that our percent spent is right near the finish line there, sitting at 99% of the revised contract value, 78.7 million. And substantial completion, the contractual due date was in late September. So we are slightly overdue in terms of substantial completion at this point in time. And then the contractual due date for final completion is in mid-March. And there's still time left for final completion there in terms of the contractual date. Okay, and so my graphics will kind of show where we are here. So just jumping back one quarter to the second quarter, we had several areas in commissioning and one area still in construction through the end of the second quarter. And then through the end of the third quarter, we've just got a handful of areas left in commissioning that we're trying to wrap up at this point. And so just a couple of photos here of the pre-substantial completion status of the project. The site is largely restored and, you know, looking very, very similar to what it did pre-construction. And then just the project summary here. So approaching 600 RFIs and 2,200 submittals reviewed and completed. Up to 630 coordination and shutdown requests. And again, these two items, they're dwindling down. There's not too many more of these left to go here. As far as construction completion efficiency, we're at 75% complete on punch list items, and this is still very good. It still shows the contractor is eager to get to that final completion finish date. Even as, because we've added punch list items, you know, as we've gone through and as I've given subsequent presentations here, areas have been finished and punch list items have been added to the overall list. So we're still, you know, looking very good in terms of the percent complete and staying on top of those final completion items. And then we don't have any outstanding claims that we've not been able to resolve. We're still approximately a month late, or tracking to be approximately a month late or so, and then still at 14 executed change orders.
Rick, any concerns with being 24 days late? How much longer that will be?
So I think we're probably looking at next month, and I'm optimistic a little bit, but I think we're looking at probably next month to
And
get to substantial
Will
completion.
that, do you anticipate that impacting that May final completion date?
I think they're very eager to complete the project and get to the finish line. And so I think I'm pretty confident that March date for final completion, that they should be ahead of that, just based on what I've seen so far in their performance.
So they're hustling to get it done.
Yeah.
Is the delay, or the delays related to the change order? What, the,
The delays, so I will add that a couple of claims that we've settled have resulted in some time for them, 21 days to be exact. And so that is not memorialized in a change order yet, but it has been communicated, you know, through claim responses. So they are entitled to some time. But as far as their delays, we're going to have to work through responsibility and whether contractor or owner, and just come to a negotiated agreement there. Okay. So our active construction projects here, we've got this list of projects active through the third quarter. I'm going to quickly jump in here and just mention, so on the roofing project, okay, the last time I presented this in the second quarter, there was a larger, we were over contract time, a larger amount, and the substantial completion delay has been reconciled. So you can see here that has played out in the contingency utilization and change order percent. And so the remaining delay or lateness here is a result of final completion delays. So the contractor has achieved substantial on the roofing project, and the only holdout at this point is a warranty paper or a warranty provision. So we're as soon as we get that, we're at final completion on the roofing project. Yes, any other questions on any of the other projects in construction?
Now, as usual, your report is very positive, but I have a negative question.
Okay.
Is there anything out there that's causing you heartburn?
On this list of projects?
On any of the projects that you guys are involved with?
I'll say this, nothing is causing me to lose sleep at night. But, you know, there are some there's some challenges and things that we're working through in the normal course of, you know, administration of these projects. But nothing that's keeping me awake at night. Is that fair? Does that answer? Go ahead, Sam.
Mr. Sultan, I'll add, if you would have asked me that question, during the last quarter, I probably would have mentioned that I would have been a little bit apprehensive about the fact that Reservoir Park was trending, towards being delayed. However, sort of seeing how the grand opening sort of unfolded a couple of days ago, and, you know, the nice weather we had and the peak foliage sort of in full effect, right? And how well it all went. It's almost like sort of, I would say, well, it happened for a reason, but bad cliche, right? It's actually approaching now, final completion. Obviously, we've seen the Nova Parks folks take ownership, start moving their equipment, gear, items into the park and pretty much open to the public, right? We do have some final administrative items that we have to settle out.
Yeah.
And, you know, the conversation with the contractor about closing out the contract, right? If I had to pick at anything, it would probably be that.
Mr. Sultan just seeing everything's going so smooth, so you're looking for something,
Well, I mean, there's gotta be something.
something out there.
I know these guys are good, but they're not perfect. Or are they? I don't know.
Job well done.
Yeah.
Yeah, thanks.
As I've said many times, they do a lot better than my group did when I was at Fairfax, I tell you that.
If I could just add, overall, we're seeing lead times and stuff get better. I think the one area that there's still a struggle is on the electrical side, both with contractors to perform work and then lead time on equipment. So I think, you know, from my perspective at the higher level, that's still one area that I have concern with, but, you know, we do what we can to control it.
Same things occurring on the commercial side.
Right.
Okay, our next list is our completed projects. So these were the two projects that reached the end of construction final completion in the third quarter here. And for the second one there, the Broad Run reclaimed water pump station capacity, I'm just going to give a shout out to Nick Fugaro and Noel Bropes Whitcomb from my group that did an excellent job managing this project and, you know, helping it to finish with really good numbers. And also give a shout out to the design engineer, CDM Smith, that really gave us a good, tight, solid design for this project as well.
Ryan Morris from our group.
Ryan Morris also did support, yes. Yeah.
I think you make a good point. I mean, you guys are good, but if you didn't get good plans, you'd be in trouble. So the design end is working very nicely.
Thank you.
And then just our last one here is just the 6-month look ahead. We've got the Trap Rock standby generator project on the docket here for starting construction in the next 6 months.
I think we asked them during the presentation. Thank
Okay.
you.
Well, thank you.
Thank you all.
As a fanatic bike rider, I'm just glad you're paving the Rig detour.
Nice, long way to.
Yeah,
It's a smooth transition.
yeah. Any other questions?
Thank you.
Thank you, guys. Gals. Next item is the capital spending summary report.
Good morning. I'll do a real quick here, just review of this. This is spending through the end of September. So spending on capital projects was about 79.5 million. If you compare that to the previous month at the end of August, there was about $10.3 million spent in September. That 79.5 is about 96% of the mid-year reforecast. So that's the dashed line on the graph. And of note, it's about 86% of the original projection for the month of September. So those numbers don't cause me to lose any sleep, but if there's any questions, I'll certainly be happy to take them.
Thank you.
Any questions?
And good job.
I guess that's it. Do I have a motion to adjourn?
I'll make the motion to adjourn.
A second, all in favor?
Aye.
Thank you, everybody.
All right, thank you.
Very well done, gentlemen.
Thank you, everybody.
Meeting.
Thanks, everyone.